Hello, I hope you're doing well. Today in calculus, we are looking at section P2, part 1. What we're going to be looking at is estimating slope and then finding exact slope between 2 points. We also want to be able to find the slope and y-intercept of a line that's in standard form. And we want to be able to find an equation of a line passing through a point with a given slope or given 2 points. So this all probably sounds familiar to you, and you might be thinking, oh, I know how to do all this. Well, it's going to be a little more complicated, though, than the types of slope that you have worked on before. So just remember that slope is a measure of the number of units a line rises or falls vertically for each unit of horizontal change from left to right. So when we're talking about slope, I'm sure you've heard it called rise over run. When we're talking about it in a more mathematical way, we say delta y over delta x. Delta means the change in. So it's the change in the y's over the change in the x's. So if I want to find the change in the y's, I just subtract them. That's how I always find the change in them. If I want to find the change in the x's, I just subtract those. Probably already know that formula. All right, so if I am looking at this, I can see that has a positive slope. And I want to just explain slope for a minute. When you have a horizontal line, that's zero slope, okay? As I turn it, that might be about 1/10, 1/2. When I have a slope like this that forms a 45-degree angle with the x-axis, that's going to be a slope of 1. It's up 1 over 1, up 1 over 1. So this is a slope of 1, slope of 2, 3, 4, 5, 6, 7, 100, a million, 10 million, 100 million, until finally this slope right here is called undefined. And this slope right here is so steep we can't even define it. The rise is infinity and the run is 0. So infinity divided by 0, that has no meaning. It's undefined. Okay? All right. One way we can find slope is just by counting, and we don't even have to actually find the numerical value for the points. I'm just going to find a point here that is on the kind of like crosshairs, I guess you'd say, where those intersect, and then we can just count. So 1, 2, 3, 4, 1, 2, 4 over 2 is 2. So that's a slope of 2. Find the slope between these. Well, I'm going to find my slope. I'm going to do 2/5 minus 1/5 over negative 3/4 minus negative 1/4. So that becomes plus. Now, you could just work with the top, work with the bottom, and then divide. I'm going to show you another way to do this, though. What I'm going to do is I'm going to think, what's the common denominator for 5, 5, 4, and 4? It'd be 20. So I'm going to multiply the top by 20 and the bottom by 20. If I multiply by 20 over 20, that's just 1. When I multiply this, I've got 20 divided by 5, that's 4, times 2 is 8. I've got 20 divided by 5, that's 4, times 1, that's 4. I've got 20 divided by 4, that's 5, times negative 3 is negative 15. And I have 20 divided by 4, that's 5, times 1, that's 5. And so now I've got 4 over negative 10, and that's going to be a slope of negative 2/5. Okay? That's good. Now, here's another way I can do slope on my calculator. I just want you to be familiar with this. So I'm going to want to use my parentheses. If I want to get to a fraction, I can do that by, I can just type it in as a fraction, actually. Let me do it this way. So I can do 2/5 minus 1/5. And that's okay to put it like that. And then I just made sure I put it in parentheses, divided by, parentheses, negative 3/4 plus 1/4. And we get that answer, and we do a math frac, and negative 2/5. So negative 2/5. Now, I personally think it's faster just to do it, this way than it is to even get out that calculator. But just want you to have seen it. Okay, draw a line through 3, negative 4, with each of the following slopes. So 1, 2, 3, 1, 2, 3, 4. There's 3, negative 4. First, I want a slope of negative 1/2. So from here, I could go down 1 over 2, but I could also go up 1 and backwards 2. That's still a negative slope. And so, should get a straight edge, but good enough. So there's a slope of negative 1/2. See, negative slopes have to be going downhill from left to right, Positive slopes, uphill. So there's part A. Okay, for part B, we want a slope of 3 now through that same point. So here's that 3, negative 4. And I want to have a slope of 3, so I'm going to have to go up 3 over 1. And that's what a slope of 3 looks like. Just getting used to understanding what these slopes look like. Okay, a slope of 0. Well, remember that slope of 0 looks like this. It's a horizontal line. We rise 0. We run as much as we want. See, 0 divided by anything, even infinity, is just 0. So if I'm going to do that kind of slope, that's just going to look like this. Just going through that point right there. So there's my slope of 0. Call that C. And finally, my undefined slope, that's going to come right down through it. It's going to be a vertical line. That's undefined. D. Okay, given the point with the coordinates of negative 2, 4 with a slope of 2, find 3 additional points that the line passes through. You might want to pause the video and see if you can figure this out on your own. I'm going to show you though. Go ahead and pause and then check your answers. If I want to have a slope of 2, that means that I would have to go up 2, so that's 6, and to the right 1, that would put me at negative 1. I could do that again. I can go up 2 from here, that would put me at 8, and then I would have to go to the right 1. From here, I would have to go up 2 to the right 1. So there are 3 additional points. Now let's say we went the other way. Let's say we went down 2. Well, then I'd have to go to the left 1. And so there are 4 possible points you could have had. Slope and y-intercept. Given y equals mx plus b, the slope of the line is m, and the y-intercept is b. Find the slope and y-intercept of the following lines. All right, so if I have this, I might want to put this into y equals mx plus b form. And by now, you should be able to do this pretty quickly. I'm going to take that over. We're going to divide by negative 2. And we've got y equals 3 halves x minus 5. And so now I can see that the slope is going to be 3 halves. And the y-intercept, if I just want to write it as, the y-intercept, I can put negative 5. Most people write it as a coordinate, though, so 0, negative 5. Okay, x equals 4. Well, look at this, guys. I'm going to come over here. If I want x equals 4, here's x equals 4. Here, that is the point 4, 1, 4, 2, 4, 3, 4, negative 1, 4, negative 2. Here's what the slope, here's what the line x equals 4 looks like. Every point on here has to have an x value of 4. Remember, 4, 0, 4, 1, 4, 2, 4, 3, 4, negative 1. So x equals 4 looks like that. Think about it. What's that slope? Undefined, right? And the y-intercept. Well, does it ever cross the y-axis? No. So there's none. Okay, and then for this one, y equals 4. I'm going to go to y equals 4 right there. I need the point 1, 4, 2, 4, 3, 4, 3 and a half, 4, negative 1 half, 4. You get the idea. There's the point. There's the line, y equals 4. That slope is 0. I rise 0, but I run as much as I want. Whereas on this one, I would rise as much as I want, and then I would run 0. So that's undefined, because we're dividing by 0. M equals 0, B, or y-intercept, right there at 0, 4. All right, given a slope and a point, this is the point slope formula. We got y minus y sub 1, we're going to sub in there, equals m, we're going to sub in there, and x minus x sub 1. See, guys, look at this. Look at our slope formula. Y sub 1 minus y sub 2 over x sub 1 minus x sub 2. If I were to cross multiply on this, this times 1 would be y sub 1 minus y sub 2 equals m times x sub 1 minus x sub 2. And all they do then is they just get rid of this, right? So all that really is our slope formula with it multiplied out. But we do just plug in here, here, and here. We really could do it here as well, okay? That's where it comes from. So anyway, I've got y minus my y value equals m times x minus negative 2, that's plus 2. So I'm going to have y equals negative 2/3 x minus 4/3. And does it tell us a form? Doesn't say, so we'll just give it like that. Okay, here's our point, here's our slope. A slope that's undefined can actually be any number over 0. So I could use the formula. I could go y minus 4 equals 1 over 0 times x plus 3. What does that mean, though? That doesn't mean 0, so I can't multiply these by 0. I would actually have to multiply this side by 0 and this side by 0. So if I do that, my zeros cancel out. And if I multiply this side by 0, I'm just going to get 0. So now I would have 0 equals x plus 3. Solving this for x, I would get x equals negative 3. That's my equation. Now that's kind of a weird way. What I prefer to do is just say, okay, negative 3, 4. That's right there. I want my slope to be undefined. Can you see how that's just the line x equals negative 3? Okay. All right, last one. Given 2 points, find the slope, then use the point-slope formula. Find the equation of the line through these points. Okay, a little tougher. So we're going to find the slope. I do my y2 minus my y1. My x2, and of course you can go this to this and this minus this too, it would be the same thing. Anyway, 5/4 minus 7/8. Okay, now I like to get rid of that fraction. That's the way I like to do this. It's much quicker. 4, 4, 4, and 8, common denominator is 8. I'm going to multiply by 8 over 8. So 8 divided by 4 is 2, times negative 1 is negative 2. 8 divided by 4 is 2, times negative 3 is negative 6. 8 divided by 4 is 2, times 5 is 10. 8 divided by 8 is 1, times negative 7. So I'm going to get negative 8/3. Okay, so there's my slope. I can take either point. I'll just use this one. So now I'm going to have y minus 3/4 equals my slope times x minus 7/8. All right, so finishing this, y minus 3/4 equals, distribute this, negative 8/3 x plus 8 divided by 8 is going to be 1, and then 7/3, so plus 7/3. Okay? Then I have to add 3/4. So I'm going to have y equals negative 8/3 x, and then just get a common denominator of 12. So times 4 times 4 times 3 times 3. What's that going to be? 37. Now, I want to show you a way I can check this that's really cool. So what I'm going to do is I'm going to put this line in here. I did that pretty fast, and I could have made a mistake because I did it pretty quickly. Hope it's right still, though. Zoom 6. Okay, so here's this line. Now, if this is correct, then when I have it check, I'm going to say, second trace, calculate a value when x is 7/8. So if I did this right, when x is 7/8, I should get 3/4, 0.75. Great. Just checking my other point real quick. Value when x is 5/4. So if I did it right, negative 0.25. All right, so we're in good shape. Okay? So we're still doing the linear models, and that is material that you've done before, but now we're just going to throw in some fractions and more undefined values and things like that. Okay? Remember, guys, if you need any help, just let me know. Email me, and we can set up a Zoom meeting if you're a virtual learner. Okay?